trying a new blackboard. Hopefully this works better. This is lesson 7 from chapter 10, perimeters and areas of similar polygons. This is easy, but something you're going to have to memorize, something that's easy to forget. Theorem 60, it says the ratio of the perimeters of two similar polygons is equal to the ratio of the corresponding sides. And again, let's put it into English. We have two similar polygons. It doesn't have to be triangles. It could be rectangles. It could be any sort of polygon. But if two polygons are similar, when you put the ratio of their perimeters is equal to the ratio of their corresponding sides. So the perimeter, if you find the perimeter of A, B, and C, ABC, if you put it over the perimeter of D, E, and F, it will be the same ratio as if you put AB over DE, which would be the same ratio as if you put AC over DF, which is the same ratio as CB and FE. So let's try a problem. There's only 2 theorems and 2 problems to do in this video. So here we have 2 similar triangles. You know they're similar not because of my drawing, of course, but because there's this similar thing, and the problem will say they're similar. So they want you to find the perimeter of I and G. These take a little bit of algebra. They're not totally simple. So I can find the perimeter, first of all, of RAC. Perimeter, you just add up the sides. So we know the perimeter of RAC is equal to 32. So I'm just going to, I don't think I have capacity to erase, but yeah, look at that, I erase in the wrong color. Let's see if I can erase something else. Okay, can't do that. So, hold on a second. So anyway, we can just replace this. The perimeter of RAC is 32. We have to find the perimeter of triangle ING. But we know that the perimeters, the ratio of the perimeters are equal to the ratio of the sides. They have to be corresponding sides, so you don't want to put 5 over 3. You want to put 12 over 3. So that's equal to 12 over 3. I'm just going to reduce that just to make it easier. That'd be 4 over 1. And then I just cross multiply. I'd say 32 equals 4 times the perimeter of triangle ING. And then I would just divide both sides by 4. And we'd have the perimeter of triangle ING equals 8 units. This book has no units. So that's all it is. You have to find the perimeter of one, set up a ratio between the perimeters of the 2 triangles with the ratio of the lengths of the sides. So that's the first theorem. The ratio of the perimeters of 2 similar polygons, now as I said, this will work for squares, rectangles, octagons, is equal to the ratio of the corresponding sides. Let's go to the next one. This one is Theorem 61, the ratio of the areas of 2 similar polygons. Now this is different. It's the ratio of the areas, this is going to be a little bit harder, of 2 similar polygons is equal to the square of the ratio of the corresponding sides. So here are 2 similar polygons. They use this little alpha sign for area. So the area of triangle ABC over the area of triangle DEF is equal to corresponding sides. So it's the same thing. We're going to have AB over DE squared, or you could do AC over DF squared or CB over FE squared, depending on what information they give you. Now the reason these kind of problems are a little bit more challenging is because you have to find area. And you're going to have to go back into your memory banks and recall Heron's theorem to find the area. So let's do that. We're going to find the area. They're asking here, they want to, for the question, they want you to find the area of, ING, triangle ING. So the first thing you have to do is find the area of the one that has all the sides. So remember Heron's theorem? We have to find the S first, so we add up all the sides. 12 plus 15 plus 5 divided by 2 is going to be 32 divided by 2, which gives us 16. That's just the beginning of this problem. And then we would find that the area is equal to the square root of S. This is S, so it'd be 16. And then we subtract each side from 16. So we're going to have 16 minus 15 would be 1. 16 minus 12 would be 4. 16 minus 5 would be 11. And we put all that in there and we get, I don't have the intermediate step here for some reason, but this is a perfect square, so that would come out be 4. This is a perfect square, come out and be 2, so it would be 8 square root of 11 would be the area. So it's the area of triangle RAC is 8 square root of 11. Now they want us to find the area of that little guy. So we put the areas as a ratio. So it's going to be 8 square root 11 over the area of triangle ING. And then it's going to be the ratio of the sides. Well, these are the two sides that match up. So it's going to be 12 over 3. And just make sure the difference between the area problems and the perimeter problems is you have to square the area problems. So we're going to get, again, I'm going to reduce this 4 over 1. So we're going to cross multiply, and we get 8 square root of 11. Remember, this is going to be 16 because it's squared, equals 16 times the area of triangle ING. Divide both sides by 16. Just remember the reason it's 16 is because it's 4 squared. These cross out, these cross out. So we get the area of triangle ING equals, it's not the greatest answer in the world. Looks like it's going to be square root of 11 over 2 units. And that's it. So those are the two new theorems for this lesson. And we're going to get together tomorrow. You should have watched this on Monday. We'll get together on tomorrow, go over homework, and I'll have to email you guys the practice test. So that's it for Chapter 10, Lesson 7.